All right, welcome to the second unit under Algebra 1. We are going to go into Unit 2, Solving Equations and Inequalities. We'll do the first skill in this video. First skill is equations with variables on both sides. So we're going to solve some equations. Got variables in the left and right side of the equal sign. So in this case, 2d plus 4 is equal to 10 plus 5d, and they want to know, well, what does d equal? Anytime you have an equation with a single variable, it can be solved for so that the variable is isolated on one side of the equation and everything else goes on the other side of the equation, and will simplify to a single number. So 2d plus 4 equals 10 plus 5d. We want to rearrange that so that our d's are all on one side. So I look at this and I see there's 2 on one side, there's 5 on the other. I want d to be positive when I'm done, so I'm going to subtract 2d from the left side of the equation and from the right side. If you do the same thing to both sides of the equation, the equality stays consistent. It doesn't become unequal. If you do different things to the two sides of the equation, say add 5 and subtract 2, you're not going to have equality anymore because you've changed the numbers on each side of your equation in different ways. Okay, so we're going to subtract 2d from both sides of the equation. It'll look like this. 2d plus 4 equals 10 plus 5d. That's what I start with. I'm going to subtract 2d from both sides of the equation. 2d minus 2d is 0. That was the point. I don't want d's on the left side now. I only have 4 left. 10 plus 5d minus 2d is 3d. And now I don't want 10 on this side of the equation because I want to narrow it down so only d is left. So I'm going to subtract 10 from both sides of the equation. 4 minus 10 is negative 6. 10 minus 10 is 0. That was the point. And I have 3d left. And now to figure out how many d is worth all by itself, I need to undo multiplication by 3. If 3d's is equal to negative 6, then I can divide the 3d's so that the 3d's become a single d. And if I do that on the right side of the equation, I have to do the same thing on the left side to keep the equality consistent. So negative 6 divided by 3 is negative 2. 3 divided by 3 is 1, and I'm left with 1d. So I know my d equals negative 2. Now, the sides of your equation can always flip-flop. If these things are equal, then it also follows that d equals negative 2. And that's what we will enter for our answer, negative 2. Also, before I check that, you can and should, to be certain that you got the right answer, substitute what you got back into the original equation and see what happens. So we'll do that up on the screen. If I put negative 2 where I see d, I get 2 times negative 2 plus 4 equals 10 plus 5 times d, but d is supposed to be negative 2, so let's see what happens. 2 times negative 2 is negative 4. 5 times negative 2 is negative 10. And it is true that negative 4 plus 4 is equal to 10 minus 10 because both of those things are equal to 0. 0 equals 0, so I do have the correct number for d. I can know that without checking my answer. So if I did something wrong and I got a number that wasn't true, I would know it before I entered my answer, and then I wouldn't have to get that problem wrong. I could rework it before I checked it on the screen. All right, next problem. We're going to solve for m. We'll do that on the screen this time. So we have negative 7 plus 4m plus 10 equals negative 2m plus 15. So we're going to put all our m's on the left side of the equation because they will be positive that way. I can get rid of the negative 2m by adding 2m. So I will have 4m plus 2m on the left side of the equation. That gets rid of this part. And then I want all my numbers to be on the right side, so I'm going to combine, first of all, negative 7 and 10 is 3. I can get rid of those. Now I want the 3 on that side, so I'm going to subtract 3 from both sides. 15 minus 3 is 12. And I have done several steps, but I just wanted to show you that you can think through it and write your work in a different way, and that's fine. So now I've got 4m and 2m is 6m equals 12. And if I want to know how many a single m is, I'm going to have to undo multiplication by dividing. So 6 divided by 6 on that side, 12 divided by 6 on this side. The 6's cancel, and I'm left with m equals 12 divided by 6 is 2. So m is 2. And again, let's check to see whether my solution is true in the original equation. So I get negative 7 plus 2 times 4 is 8 plus 10 should equal 15 minus 2 times 2 is 4, so minus 4. This is 11. 10 and 8 is, well, let's work from left to right. So negative 7 plus 8 is 1. And it is true that 1 plus 10 is 11, so I am totally certain that this answer is correct. We'll go to the next one. All right, they're using e as a variable here. So we want to get e on one side of the equation. We want it to be positive, so it would make sense to take the 7 e's away from both sides so that you're left with 2e on this side. So you get 2e. So 2e minus 7 equals negative 11. Then we want our constants over there, so we're going to add the 7, and that leaves us with 2e on this side. If we add 7 to that, we have negative 4 left. And if we divide by 2, we get e equals negative 2. Now let's check our answer in the original equation. 9 times negative 2 minus 7 is supposed to equal 7 times negative 2 minus 11. Okay? Now, this is negative 18 minus 7, and that's supposed to equal negative 14 minus 11. This is negative 25. This is also negative 25, so we've gotten the correct solution, which was negative 2. And we are done.